now that we have looked into the different basic syntax, we're going to start with one of the numericals from your course. So again, uh, command window, current folder, workspace. So since we're writing a code for one of the numericals that we need to use, so we want to write it in a script file, right? So I click on new script so that I create my editor window. So rather than writing my commands on the command window, I'll write the entire syntax or the entire program on the editor window, right? So I increase this because that's where most of my code is going to be. And then I have my command window. So here we're going to start writing a code for one of the numericals that you have. And as you can see again, to revise, we are in the current folder here where the trial code we just executed just now in the previous video. So here, so that's the current folder. If I try to save this file, it's going to be stored in this current folder, right? So now we're going to do a numerical. So if you can see this numerical on my screen is this, right? So I hope you have solved this manually. It's for summation of coplanar forces. So here you have different forces, and we have to find out the magnitude and the position, that means the angle of the resultant for a system of forces. So there are like 1, 2, 3, 4, 5, 6 forces. So this is the manual calculation that you do, right? So this has also been calculated for you, and so that we can check how it works on the MATLAB program as well as manually, right? So here you see this, there are 6 forces and there are angles given here. So what we do is we have to find the summation in the x direction, summation in the y direction. We find the resultant, find the angle of the resultant force. So same things, we are going to try and write a code for it on MATLAB, right? So what we do is, first of all, we can save this so that we later on it doesn't ask us again. So here I can save it as program 1, let's say. Okay, so here on the current folder, you can see this is the new file that has been created, right? So like we talked about the basic commands, we are going to first write down CLC and clear as a habit. You can do that. Then what we need is that we need to input the different forces that are on the screen over here, right? So we have like 1, 2, 3, 4, 5, 6 forces. So we need to enter 6 forces in the program, right? And uh, like we did for the previous video, we can input any variable using the input function. So we are going to use that input function to enter our 6 forces. Now that you can do individually, right? Like you can write the input function 6 times, where you enter all the 6 forces one after the other, and then you have to enter again 6 times the angles. So each of these forces is subtended at an angle, so you have to enter those angles as well, right? So instead of entering, and that we can do only because the question, we can see there are 6 forces. So rather than making it complicated, we can have just one function which calls itself 6 times according to the question. So suppose another question has 10 forces or 3 forces. That can be, the same code can be used for both. So we can look into a way of inputting or writing a code which runs itself according to the number of forces that are there in the question. So that's what we're going to do here now. Okay, now, so first we need to define uh, how many number of forces are there in the question. So for that, I'm going to write or put that value into a variable. So let's say I take a variable n equal to input enter the number of forces, right? Simple. So when this line gets executed, it'll ask me for a value. If I put 7 or 6, let's say in this question there are 6 forces, if I enter 6, the value 6 gets uh, assigned to the variable n. So that will define that there are 6 forces that are there in the question. Right? Now each of these 6 forces has a magnitude and has an angle. So we have to enter the magnitude and the angle that n number of times. So for that, as we use in the other code languages with C or C++, we use the for loop, right? So the same thing we can use here, and the syntax for it is for, let's say I give a variable I equal to 1 is to n, right? So the variable I executes itself from 1 to n. That means if you enter 6, it's going to be 1 to 6. And you end it with end, right? So this is the syntax for the for loop, right? Now within this for loop, I have to enter the force and the angle for each of these, the magnitude and the angle for each of these forces, right? So for that, I can sort of try to pitch in the forces. So what I can do is I can write if, let's say for force I equal to input, sorry, right? And let's say now f small f, let's say, is for force, and let's say small a is for angle input, right? So using these two commands, I can enter the value of force and angle 6 times each. So for the for loop, if I is 1, f1 and a1, it'll ask me the values first. Then it'll run again for 2, so I have to enter f2 and a2. Similarly, it goes on for f6 and a6, right? But since we had seen in the syntax video, in the previous video, that this input function is executed once you enter a value, and of course it is stored to the variable f or a in this case. But on my command window, I would not get any prompt of asking me for a force or an angle. So I might make mistake, or let's say if it's asking for 6 times, I might type in 5 times and think there's an error. So the easier way is if I can get a prompt. So to get a prompt to enter a force, I can write an extra command over here as fprintf. So as I was talking about fprintf earlier, this will execute a line which is which simply pops up on your command window as a prompt, right? So here what you can do is, as a prompt, you can type in the text as enter the force, okay, in Newton, let's say, right? So I can write like this, enter the force in Newton, so it will ask, so I would know that it's asking me for the force. And similarly, if I can type in this here and I ask for, just enter the, let's say, angle, enter the angle in degree, let's say. So I know that it's asking for the angle, right? But another problem here is I do not know how many or which force it's asking me for out of all the 6, right? And therefore I might make a mistake or interchange between force and their angles. So what I can do here is I can call in which the value of I over here. So I would know that it's asking me the first force or the second force or the third force. So what I can do is I can write percent %d, percent %d in n, and let's say equal to, and I'll give the value I. So using this and percent %d and calling the function I, so if it is executed for the first cycle or for the first loop, I would know it's asking me for force 1 and angle 1. Similarly, if it's the loop is running for the third time, it'll ask me enter the force, third force, something like that, right? So I would know the different forces that it's asking me for. right? So I can write enter force 1 in Newton and it's calling I, enter the angle in degree, or enter the angle for 1 for force in D, that is, let's say I, in D in degree. So I would know that it's asking me for the first force in the first loop and the first angle, or the third force and the third angle, like that, right? So this is my loop where I enter all the six forces and their angles. So I can enter all my six forces and angles, and all of it will be stored in an array or a matrix of F, where F has six values as well as A has six values in this uh, particular problem, right? So that's how we're going to enter. Right? Now, next, what we do is we need to calculate the resultant force, right? So if I look at the numerical here, as you know, we have to find the summation of x forces and the summation of y forces, right? Y-axis forces. So and all of it is stored in a value as fx and fy, right? So each of these angles, if you are working out manually, each of these forces is sort of components of each of these forces is uh, calculated for the x-axis as well as y-axis, right? And all these x-axis components are added and all the components of y-axis are added, right? So to do that, I need two variables which stores the values of the x-axis components and the y-axis components, right? So we need to define those variables first. So let's say resultant in the x-axis, and I give a value 0 to it. Similarly, let's say another variable r small y equal to 0. So what I'm trying to do here is I'm assigning two different variables value 0, where later on this value gets updated as and when the components keep adding themselves, right? So I need to define that first, right? So let's say I divide my program by some sort of text by writing that from here onwards it's like calculation for the resultant forces, right? So it indicates to me that this is like below this line, it's about the calculation of the resultant forces, but I don't want this line to be executed, right? So to do that, I write a percent sign before a line. So if I write a percent symbol before a statement or a command, it does not execute that line, right? So this is what calculation for resultant force is. So from here onwards, I can write my code for the resultant force. So here you have Rx and Ry being defined as values 0. Now here I need the x components and y components of all the six forces being added. Right? Now to do that, again, I need a for loop. So I write for I equal to 1 is to n, and I close it with n. So within this, I need to add all the components, and therefore I need this Rx and Ry to run 6 times and keep updating itself. So the command for it is Rx equal to Rx plus. So first, when the loop is executed for the first time, the Rx here, the second Rx is going to be 0 because the earlier value that is being defined is 0, right? So 0 plus. Here I want to execute the first value of force and its angle, right? So the cos of that angle. So here you can see, let's say 150 is the force, the cos angle is 30. So 150 cos 30. Right? So similarly here, I need the first force to be multiplied with the cos of the angle. So how do I do that? And I know the force is stored as Fi. So if it is 1, so if I write Fi and it's being run for the first time, it's going to be the F1, the first value in the force, right? And I multiply it with cos of Ai, right? Now, force F, if it's running for the first time in the first loop, so this is F1 into cos A1, right? Now that's the command for uh, you are finding out the x-axis component for all the forces, right? And then I put a semicolon. Now, if I write cos and the angle, it refers to the radian. So if I have entered angle in degree, if you see, if I've entered angle in degree, I would have to write the command for that is cos d, right? So this is my final expression to find out the summation of the x-axis components or the resultant of the x component, Rx equal to Rx plus Fi into cos d A1. Similarly, I can have it for my y component. So I write Ry being equal to plus F1 cos. So instead of cos, it's going to be sine, right? So again, sine d if the angle is in degree. So here Rx and Ry will save the resultant of the x components and the y components. So it's basically your fx, summation of fx and summation of fy, right? So that is executed and carried out here. Now, what do we do next is we calculate the resultant. So how do you get resultant if you do it manually? You have R equal to summation of the squares of your Rx and Ry or the resultant components and square root, right? So that's what I'm going to write. So I'm going to define another variable, let's say R being equal to the command for square root. It's quite simple. So you can write sqrt, right? And then within parenthesis, you can write Rx to the power 2 plus Ry power 2, right? So this will, if this line executes, it will find out the resultant, okay? And let's say I want to find out the angle. So here manually you find out alpha, the angle, as tan inverse summation of the y component divided by the summation of the x component. So similarly here I can write, let's say, angle of resultant AR being equal to, so since we have to find out tan inverse, the command for it is A tan, right? A tan within parenthesis, we know it is Ry divided by Rx, semicolon, right? So this will save my angle or the resultant angle as AR, but the resultant angle saves itself as radian. So you need to convert it into degree. So I can write, let's say, ARD as a variable, and I save it or I convert the radian, AR radian, into degrees by multiplying 180 by pi. Okay, so I hope you know this. So you convert your radian into degrees and save it as in a variable named ARD, right? So this is how uh, on the mathematical calculations to find out resultant and the angle. So here we complete on the calculations, right? I hope you have gone through this. So in this top part, we are entering the different forces and angles for individual forces in a loop and then calculating in a loop the resultant x components and the resultant of all the y components summation, and then we find out the resultant force and the angle, right? Now the next step is representing or representing the results in as text on the command window. So we know that the program has run, because if I run this, of course all these variables, the resultant variable and the degree variable will be created, but it will not be displayed on the screen. So to display it, as we have already seen, I write fprintf, right? Fprintf, and within parenthesis you can write your what you want to present, right? So let's say I want to find out first the summation of the x-axis and the y-axis. So I'll write the summation of, let's say, x-axis forces Rx is equal to, I want to represent it here. So let's say I represent it as a float. So and with decimal, let's say 2, right? And it would definitely be in Newton. So I can write Newton here. And as I was saying, you can write \n to take the cursor to the next line after this line is executed, comma rx, right? So here if I write rx value will be represented here as percent point to f, right? So here I'll get the summation of the x-axis forces, right? Similarly, I can do this for the y-axis forces, and I write ry and I call ry. Right? So here I get the summation of x and y forces. Similarly, I can have a command for or a print code for finding out the resultant. So I can write the resultant force, let's say R is equal to, and here I call the variable R, and now I need to know the angle, right, or display the angle. So I can write the angle between the resultant force and the x-axis is, let's say, I write this as percent point to f degrees, right? And I call the variable which stores the angle in degree, which is a capital R D. So this is the variable which saves the resultant in D, right? So I hope you went through, or you have gone through all of these lines of code. I hope you understood. First part, we are entering the forces. Middle part, we are calculating the resultant and finding out the angle. Third part, we are displaying the results, right? Now let's run this program and see whether it matches with our uh, with the manual calculations, right? So as you can see, it's start over here, so it's not saved. Once I click on run over here on the top, it's going to execute. Now in the next few minutes, you want to look at the resultant not on the editor's window, but try to look at the command window and see how it works, right? So I'll come up and have my question on the right hand side, and I'll run this program and see how it works. So enter the number of forces. So we have 1, 2, 3, 4, 5, 6 forces. So I enter 6. Enter the force 1 in Newton. So let's say I enter 150, right? Next is enter the angle for force 1 in degree. So the angle, so now this two lines of enter force and enter angle will be executed 6 times since it's in the for loop, right? And here there's a problem here that when I am entering the angle, I need to enter the angle for all the forces in the same direction. So if I'm writing 30, that is from the x-axis anti-clockwise, I have to use that same sort of direction for all the forces that I use. So if I type 30 over here, which is the anti-clockwise direction from the positive x-axis, it's getting stored in the force 1. So next command is enter the force 2, which is 100. Angle for force 2 is from the x-axis anti-clockwise. Now this is 90, right? So I write 90. Enter the force 3 in Newton. So this is 250. And what's the angle? It's 90 plus 30. So 120, right? Then enter the force 4 is 125. Angle is 180. The next fifth force is 300. Angle is, this is 180, this is 50, so this is 40. So 40 plus 180, so it's 220, right? So 220. The sixth force is 200, and the angle is clockwise from positive x. So this is 40, so 360 minus 40, so 320. So 320, right? Just a second, unrecognized function. So did we write arx somewhere? Okay, so there's an error over here because you see it was ARD. I need to convert AR to, or the radian value to degree. Now ARX is not defined anywhere. That's why the error, right? So I resolve it and Of course, the sad part is you have to run again the program. But before we run this again, I want to show you the workspace. If you see the workspace here, we had entered force and your n, which is total number of forces. You have an array of all the different, or matrix of all the different forces. Your a value has all the values of the angles, right? So it's all stored over here, and it has somehow calculated the values over here as well, but it did not display on my command window because there was an error. So it's executed actually, but it did not found an error. And of course, because the angle in the degree was not running, so we have to run this program again and enter the values again. But as you can see, the workspace has these variables created. Now if I run again, I'll have to enter all these forces again, so we'll do that really quick. So run it again. It's 150, which is 30, 100, 90, 125, it's 180, 300 is plus 180, 220. Then you have 200 and 320, right? And some other error on integers or logical values. Just a second. I think I have an error over here. So I think there should be a multiple sign over here. Since I did not see that again, just a few more minutes. I hope this runs. 100, 250, yeah. So finally it executed. So you see the summation of the x forces is minus 196.70. So manually, if you see, we have also got the same value, minus 196.7. Y-axis summation 70.11, manually also 70.11. The resultant force R is 208.82. That's what we calculated manually. And the angle between the resultant force and the x-axis is minus 19.62 degree. Why minus? Because we took the anti-clockwise direction, so this 19 degrees is probably in the clockwise direction, right? So that's the negative sign. So this is what you get on the MATLAB, right? So this is the code. So this code is works because we did calculate it manually as well as on the code, and the results match. So the good thing about MATLAB now is, since we have made a common sort of program, we can vary the number of forces, the magnitudes, and the angles, and the same code is going to work for any n number of forces in n angles, right? So that's what the first program is on. Okay, I hope you've understood this. Thank you very much.